Okay guys, so in today's video we are looking at two exam style questions for basic differentiation, and it's year 1 core math, so it's year 1 pure mathematics, okay? So it's appropriate for AS level pure math students, so students in year 12 and even year 13 guys, and also GCSE further math students and IGCSE students as well. Okay, as ever guys, feel free to obviously pause the video, try and attempt the question, okay, and then come back and press play and then check your answer with me, okay. Question number 1, the curve C has the equation y is equal to 2x squared minus 12x plus 16. Find the gradient of the curve at the point 5, 6. So gradient of a curve means that I have to differentiate, so I'm going to work out what dy by dx is. So dy over dx, so dy by dx or dy over dx, okay, so we bring the power down, okay, as a multiplier and then reduce the power by 1, so 2 times 2 is going to be 4 and the power comes down by 1, so it's just 4x, okay, so it's just equal to 4x, okay, and then minus 12x just differentiates to minus 12, okay, and then plus 16 differentiates to 0, okay? If you differentiate a constant, it just goes to 0. Okay, so this is dy by dx. So the gradient at this point, so I'm going to sub in the x coordinate of 5 into here. So I have 4 lots of 5. So 4 times 5, guys. So 4 times 5. And then take away the 12. Well, 4 5s are 20. Take away 12 is equal to 8. Okay, but feel free to obviously use your calculator, okay, to check your answer or answers if you need to at any stage. Okay, apologies guys about any like jerkiness in this video, so please forgive me for any like jerkiness. Okay, so we differentiate, so the power comes down as a multiplier and then we reduce the power by 1. Okay, this is, remember, is 12x to the 1 here. 1 times 12 is 12 and then the power comes down to 0. X to the power of 0 is just 1, so that just disappears, and then differentiating a constant always goes to 0, guys. Okay, and then I subbed in the x coordinate of 5 into dy by dx, okay, to work out the gradient at that point, okay. So the gradient at point P is equal to 8, okay. So the gradient, so I'm going to put letter M here, okay, M is equal to 8, guys, okay, for that one. Okay, this is question number 2. A curve has equation y is equal to 3x squared plus 24 over x plus 2, where x is bigger than 0, so this is what I call my domain. Okay, find in simplest form dy by dx. Okay, so let's just write the format here a bit more simpler. So we'll have y is equal to 3x squared, so that stays the same. 24 over x can be written as 24x to the minus 1. Okay, making sure that you're happy with your negative indices. Okay, and then I've got the plus 2 there. Okay, so taking our time with differentiation, okay, so dy by dx, guys, okay, so differentiating y with respect to x, okay, dy by dx or dy over dx, okay, so the power comes down as a multiplier and then the power goes down by 1, okay, so 3x squared, so it's 3 times 2, which is 6, and then we reduce the power, so it's just going to be 6x, okay, so it's just 6x. And then differentiating 24x to the minus 1, okay, so 6x goes to 24 times minus 1, it goes to minus 24, so it's minus 24x to the minus 2, okay, so that's my answer for part A. Okay, now if you're interested, I can write it as 6x take away 24 over x squared. That will also be appropriate and plausible, guys. Okay, for that one. Okay, So either answer is appropriate for the examiner. Okay, again, apologies for any jerkiness, okay, in this video. Okay, that's meant to say like the number 6 there, so hopefully you can forgive me, okay, because I think my laptop's been a bit jerky today, so apologies for any it's about the number 6 there. There we go, that's a bit more clearer. Okay, for part B, hence find the exact range of values of x for which the curve is increasing. Well, that's when dy by dx is strictly greater than 0. So that's when this part, okay, so we set 6x minus 24 over x squared. So this is when the derivative, okay, is bigger than 0. Okay, whenever you see like a curve is increasing, okay, think of it as an inequality and it's bigger than 0, guys. Okay, so we're going to obviously solve this as we do normally. Okay, so if I times everything by x squared, I'm going to get 6x cubed, okay, take away 24x, take away 24, and that's going to be strictly greater than 0, okay. So factorize the 6 out, so I get 6, and then I'm going to have x cubed, take away 4, okay, is greater than 0, okay. So we're looking for when x cubed minus 4 is greater than 0. So that means we have one root here, okay. So dividing both sides by 6, we get that x cubed, okay, is, strictly greater than 0. So x cubed minus 4 is greater than 0. Okay, it's a cubic, equation. Okay, so we're going to find out the roots now to this equation. Okay, one root is when x is equal to the cube root of 4. Okay, so that's when we have one root. Okay, for that. Okay, so that'll be equal to 1 root here. So I'm guessing it will be above this point here. Okay, so I'm just trying to think, guys, here, to think about any easier way to solve this inequality. Okay. Okay, so I think our answer will just be x is less than, okay, the cube root of 4. Okay, so that'll be like your solution for that equation. Okay, so the exact range of values, okay, for which the curve is increasing, well, that's when we have x is less than the cube root of 4, okay? For that, okay? So hopefully it makes sense, guys, okay? Right, guys, that takes us to the end of this short video on basic differentiation year 1 core maths. Okay, it's from the physicsandmathstutor.com. Okay, and it's looking at exam style questions involving differentiation. Okay, if you found this useful, please like, please comment, please share, and please subscribe, and I'll see you all inside the next video. Okay, bye for now.